In our last video, we had a look at what volts, amps and ohms really were. Now, if you remember, that means that voltage is equivalent to the pressure in an electrical system, and we measure that between 2 points. It's the pressure difference between two different points. Amps was the current flow through a system, and ohms, the resistance, was the resistance to flow through that circuit. Now, this video, we're going to have a look at how those things are related. Now, there was a clever bloke who came up with Ohm's Law, Mr. Ohm, and he realised that volts was equivalent to the amps times the ohms. So basically, the more voltage you've got, the more current you've got for a certain resistance. Now, the resistance is like a physical property of the circuit, so certain components in there will have a set sort of resistance, although it can change with temperature and things like that. So what we come up with is V equals IR. Now, this is a bit of a leap because all of a sudden I'm using different symbols. In engineering, we tend to use the letter I, pay attention, we use the letter I to denote current. The reason for this is a long historical thing because the letter C had been already used for charge in coulombs, so they couldn't use that. So we use the letter I for current. We use the letter R to show resistance. So that's resistance in ohms using the symbol omega. I didn't make the rules. I'd just like to make that perfectly clear. And what this means is that as the voltage goes up, the current will go up for a certain resistance. Or, if we change the resistance, the current will change for a certain voltage, which is quite useful. And in fact, we use that for things like temperature sensors. If you've got an engine temperature sensor, we put a little resistive element in the coolant, and its resistance changes as its temperature changes. So that means that the current going through it for a given voltage will change as that resistance changes. And that allows the dashboard to then measure how much temperature there is in the engine. So if that current's then going through a gauge, more current going through the gauge makes the gauge move more, and that gives you your temperature gauge. Very simple system. Sometimes when we're working on bits of car, we need to understand what the resistance of something is to work out whether it's broken or not. And high power things have very, very low resistance, and you can't really measure it with a multimeter. It's not accurate enough at anything below about 10 ohms. So then we have to work it out, and we can work it out by rearranging this equation again. Resistance equals voltage over current. It's very useful. Well, it is when you get into the heavy engineering side of things anyway. So that's the relationship between volts, current and resistance. Ohm's Law. Quite a useful thing if you're doing fault finding on your car and you want to find out why something's acting a bit weird. All good stuff. Next up, I think we'll deal with power. Oh yeah.